Now this is the fourth example of these chapters, and in this chapter you are given the value of resistance, which is 60 ohm, the value of inductance, which is 0.5 Henry, and the value of capacitance over here with the value of 8 microfarad. Right, so this three instrument was connected to the AC source with the value of V is equal to 120 volt and frequency of 60 Hertz. You were asked to find the impedance for this circuit. So what is impedance? Impedance is Z. So what is Z? Z is actually the total of the resistance in the AC circuit when these three was connected to each other. Okay, once again, what is impedance? Impedance is actually a total of resistance when R, L, C was combined or connected in series to the AC circuit. So you know that in each of these instruments, in resistor you have your own resistance, in the inductor you have your own inductive reactance, which is also the resistance, and in the capacitor itself you have your capacitive reactance, which also represent the resistance. So what is the total of all this resistance that owned by this particular instrument? It is represented by the impedance. So that was impedance. So how to find impedance? Let's see the final equations over here at the bottom. Wait, I need to change the ink of my pen first. So as you can see over here, the final equations, this is the equations of impedance. So impedance can be calculated by using this equation, which is equal to the square root of R squared, this is x-axis, plus with the y-axis, where in y-axis you have two resistance, which is XL minus XC squared. Please don't watch this example video if you are not learn or studying the chapter 13 first through my video, because you will not understand what I'm talking about right now if you didn't studying it first. So please, right? So this is the equations of impedance. So how to find these three? This as for the resistance, I have no problem on it because I was already given the value of 60 ohm. But then I have to find my XL and XC. So how to find the XL? XL is the equation of XL is equal to this one, and the equation of XC is equal to this one. So I have everything, every information to solve this equation. Actually, I have the frequency, I have the inductance, and I have the capacitance. So just substitute in that particular equation. You will get the inductive reactance is equal to 226 ohm and capacitive reactance is equal to 332 ohm. So substitute these two things plus with the value of resistance into these equations of impedance, and you will get the value of impedance is actually 122 ohm. So that was actually the total resistance in this particular circuit right now, where the L, the C, and the R was combined in series and connected to AC power supply. So that was the example, the fourth example of these chapters. So this is a continuation of questions from the example 4. So I rewrite again all the things that was already calculated from example 4. So you have your XL over here, you have your XC, and you have your value of R and the impedance itself. So in this question, you were asked to find two things, which is the effective current and also the phase angle. So to find the effective current, I just use the Ohm's law, which is V is equal to IR. So rearrange these equations since I need to find the I effective. Then you will get these expressions. Just substitute everything where the total voltage is given to you and also the total of the resistance, which is the impedance itself. Remember, I will not substitute the value of R nor XC nor XL here because this circuit was a combination between R and C. So the value of R here is supposed to be represented by the value of impedance, which is the total resistance on that circuit. So by calculating this one, you will get the value of I effective is equal to 0.985 ampere. Now, the next question was asked you to find the phase angle. So phase angle can be calculated with these equations over here, where tangent theta minus tangent theta is equal to the total of resistance in y-axis divided by the total resistance in x-axis. So y-axis, in y-axis, the resistance that was consist in y-axis is XL and XC. And in x-axis, we have only one, which is our value of R. So if I sketch these three value XL, XC and R in one graph or one axis, you will get this type of sketching, where on y-axis you will have your XL and XC, and on x-axis you will have your R. Why R is on x-axis? Because there is no effect of frequency to the value of R, right? So suppose since XL, if you still remember the short words that I teach you on how to memorize who is leading and lagging in each L and R, L and C, which is Eli is the Iceman. In Eli, the value of voltage or EMS was leading by 90 degrees to the current in inductor. Then in ice, where the current was actually leading 90 degrees compared to EMF in capacitance. So as you can see over here, originally XL was actually on the positive directions of the y-axis and XC is actually on the negative directions of y-axis. It is known that XC is supposed to be always lagging compared to XL. So we know that the value of XC is actually smaller, supposed to be smaller than XL. Hence, I will get this expression. So XL minus with XC. So the total resistance between these three, which is our impedance, was actually on the hypotenuse because this is our triangle. So on the hypotenuse is the total of the resistance, which is impedance. And the one that you need to find, which is the phase angle, is the degree between the positions of Z to the x-axis, which is our theta. So to find this one, I will use these equations. But then to use this equation, I have to know what is this value and then what is this value. So by calculating that one, I will eventually get the value of theta. So by substituting everything into this one, I will get the value of theta is equal to negative 60.5. As you can see over here, the value of XL and XC, the value of XC was bigger than XL. Even though we know that XC is always lags behind. But in this particular questions, XC was actually have a bigger number than XL. Hence, the value of difference between this XL and XC is equal to negative 106. So when this one, the value of difference between XL and XC is negative 106, then we know that the directions of XL minus XC is equal to on the other sides, which is on the negative side of the y-axis. So your theta is equal to negative 60.5 due to negative 106. The negative here is actually represent this one, right? So negative phase angle means that the AC voltage lagged the current by 60.5 degree. This is known as the capacitive circuit. So in this particular circuit, the capacitive reactance was actually more higher, more dominant than the inductive reactance. So the value of difference between XC and XL will be on the negative side of the y-axis. So the positions of impedance right now was actually on this side, with the angle between this impedance to the x-axis equal to negative 60.5 or 60.5 degree. So that was example, the continuations of example number 4.